Now let's talk about tools for securing AWS resources, starting with the first group of tools: identity and access management and infrastructure and network protection. First, everything in AWS security starts with who can access what, and that's where identity and access management comes in. At the center is AWS Identity and Access Management, or IAM. IAM is the core service you use to create users, roles, and permissions. It allows you to control access to AWS resources in a very granular way. A key concept here is least privilege, only giving users and services the permissions they actually need, and nothing more. For the exam, remember, IAM is always the foundation of AWS security. Next is Amazon Cognito. Cognito is focused on application users, not administrators. If you're building a web or mobile application and you need user sign-up, sign-in, authentication, or identity federation with providers like Google or Facebook, Cognito handles that for you securely and at scale. Then we have AWS Organizations. This service helps companies manage multiple AWS accounts centrally. With Organizations, you can apply service control policies, or SCPs, to define what accounts are allowed or not allowed to do. This is especially important for large environments where governance and security need to be consistent across teams and accounts. Now let's move into infrastructure and network protection, which is all about controlling traffic and protecting workloads at the network and infrastructure level. Amazon VPC is the foundation here. A VPC allows you to create isolated virtual networks where you control IP ranges, subnets, routing tables, and virtual firewalls. Using security groups and network ACLs, you decide exactly which traffic is allowed in and out of your resources. On top of that, we have AWS WAF, the Web Application Firewall. AWS WAF protects applications and APIs from common web attacks like SQL injection and cross-site scripting. It integrates directly with services like CloudFront, application load balancers, and API gateway. For protection against large-scale attacks, AWS Shield provides managed DDoS protection. Shield Standard is enabled automatically for all AWS customers, while Shield Advanced offers more advanced detection, response, and cost protection for critical applications. Finally, there's Amazon Inspector. Inspector helps you continuously scan your workloads for security vulnerabilities and unintended network exposure. It's especially useful for identifying issues like missing patches or overly open network configurations before they become real security problems. Together, these tools form a layered security approach, controlling identity, securing networks, protecting applications, and continuously identifying risks. In the next slide, we'll continue this topic by looking at tools for data protection and monitoring, auditing, and compliance. Let's continue with the second part of tools for securing AWS resources, focusing on data protection and monitoring, auditing, and compliance. Data protection. At the core of encryption in AWS is AWS Key Management Service, or KMS. KMS allows you to create and manage encryption keys and integrate seamlessly with many AWS services like Amazon's 3, EBS, RDS, and Lambda. In practice, this means you can enable encryption with just a few clicks or API calls, while AWS handles the heavy lifting of key storage, rotation, and durability. For most workloads, KMS is the default and recommended approach. For organizations with stricter security or compliance requirements, there's AWS Cloud HSM. Cloud HSM provides dedicated hardware security modules, or HSMs, where you fully control the encryption keys. This is commonly used in industries like finance or government, where regulations require customer-managed keys stored in certified hardware devices. Then we have Amazon Macie. Macie focuses on protecting data itself, especially sensitive data like personally identifiable information, or PII. Using machine learning, Macie scans data stored in Amazon S3 to automatically discover and classify sensitive content, such as names, addresses, or credit card numbers, and alerts you when risks are detected. This is extremely useful for compliance and data governance. Now let's see monitoring, auditing, and compliance, which is all about visibility and accountability. AWS CloudTrail is one of the most important services to remember for both security and the exam. CloudTrail records all API calls and account activity, who did what, when, and from where. These logs create an immutable audit trail that is essential for investigations, troubleshooting, and compliance audits. Amazon Guard Duty. Guard Duty continuously analyzes logs and activity across your AWS environment to detect threats, such as compromised credentials, unusual API calls, or malicious network traffic. Think of Guard Duty as an intelligent security monitoring service that looks for suspicious behavior without requiring you to manage servers or rules yourself. AWS Config focuses on configuration compliance. It continuously evaluates your AWS resources against defined rules, for example, whether S3 buckets are encrypted or security groups are too open. When something becomes non-compliant, Config flags it immediately, helping you maintain governance and security standards over time. Finally, AWS Security Hub brings everything together. Security Hub aggregates findings from services like Guard Duty, Inspector, Config, IAM Access Analyzer, and even third-party tools into a single dashboard. This gives security teams a unified view of their security posture and helps prioritize and respond to issues more efficiently. These services ensure that data is protected, activity is monitored, compliance is enforced, and security insights are centralized, forming a complete, layered security strategy in AWS.
Alright, so at this point, go ahead and pause the video. Take a moment to read the question carefully, and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer.
Now let's look at the next question, which focuses on access control and data security in Amazon S3. The scenario tells us that the data is sensitive financial data, and the goal is very specific. Only authorized users should be able to access certain S3 buckets. So as you read the options, keep this key idea in mind. This question is about who can access the data, not just how the data is protected. Here are a few clues to guide you toward the correct answer. Ask yourself, which AWS controls are designed to decide who is allowed and who is denied access to a resource? Remember that encryption protects data at rest, but by itself it does not decide who can read or write the data. Think about the principle of least privilege, which is a core AWS security concept and heavily tested in the exam. Be careful with options that suggest AWS will automatically restrict access for you. AWS provides the tools, but customers configure access. Also consider whether the service mentioned is actually designed for access control, or if it solves a different security problem, like DDoS protection. Use these clues to eliminate the incorrect choices and identify the action that directly controls and limits access to S3 resources. In the next slide, we'll reveal the correct answer and explain why it's the best choice. Correct answer is, use IAM policies and bucket policies to enforce least privilege access. Short explanation. This question is about controlling who can access sensitive data, not just protecting the data itself. IAM policies and S3 bucket policies are the correct tools to explicitly allow or deny access to specific users, roles, or services, following the principle of least privilege. Why the other options are incorrect. Encrypting the bucket protects data at rest but does not control who can access it. Relying on AWS to automatically restrict access misunderstands the shared responsibility model. Customers configure access. AWS Shield Advanced protects against DDoS attacks, not unauthorized user access. For the exam, remember, access control equals IAM plus resource policies. Encryption does not equal access management. Let's talk about encryption at rest, which is one of the most fundamental security concepts in AWS, and one that appears frequently on the exam. Encryption at rest means protecting data while it is stored on disk or physical media. The idea is simple but powerful. Even if someone were to gain access to the underlying storage, like a disk, snapshot, or backup, the data itself would be unreadable without the correct encryption keys. This protects against risks such as stolen storage devices, improper disposal, or unauthorized low-level access. In AWS, encryption at rest is deeply integrated into most services and is often easy to enable or enabled by default. Let's look at some common examples. For Amazon's 3, AWS supports server-side encryption, which means AWS encrypts your objects automatically when they are stored. SSES3 uses keys managed entirely by AWS. SSE KMS uses keys managed by AWS Key Management Service, giving you more control, auditing, and access policies. SSEC allows you to provide your own encryption keys, which AWS uses temporarily during the request. For Amazon EBS, encryption is applied at the volume level. When you encrypt an EBS volume, all data written to the volume is encrypted automatically. Snapshots created from that volume are also encrypted. The encryption is transparent to applications. No code changes are required. For managed database services like Amazon RDS, DynamoDB, and Aurora, encryption at rest is handled at the service level. Data files, backups, snapshots, and read replicas are encrypted automatically. Encryption uses AWS KMS keys, ensuring consistency and centralized control. At the center of all this is AWS Key Management Service, KMS. KMS allows you to create and manage encryption keys centrally. Control who can use those keys through IAM policies. Audit key usage using CloudTrail. This makes KMS the backbone of encryption at rest across AWS. For organizations with strict regulatory or compliance requirements, AWS also offers AWS Cloud HSM. This service provides dedicated hardware security modules, giving customers full control over key generation and storage in a highly secure, isolated environment. To summarize, encryption at rest protects stored data, AWS makes it easy to implement across services, and customers control how keys are managed, whether fully by AWS, through KMS, or via dedicated hardware with Cloud HSM. For the exam, remember this rule of thumb. If data is stored, AWS almost always offers built-in encryption at rest, and you are responsible for enabling and managing it correctly. Now let's move on to encryption in transit, which focuses on protecting data while it is moving, not stored, but actively traveling between systems. Encryption in transit ensures that data sent across networks cannot be intercepted, read, or modified by unauthorized parties. This is especially important because network traffic often travels across shared or public infrastructure, such as the Internet. The most common way AWS achieves encryption in transit is through HTTPS and TLS. When you connect to an AWS service using HTTPS, TLS, transport layer security, encrypts the data between the client and the service. This protects sensitive information such as login credentials, API requests, and personal data from eavesdropping or man-in-the-middle attacks. To make TLS easier to manage, AWS provides AWS Certificate Manager, ACM. ACM handles creating SSL/TLS certificates, automatically renewing them, deploying them to supported services. This removes the operational burden of manually managing certificates, which is both error-prone and risky if certificates expire. Services like Elastic Load Balancing (ELB) and Amazon CloudFront play a key role in encryption in transit. They can terminate TLS, meaning they handle the encrypted connection from the client. After that, traffic can either be forwarded internally in plain text or re-encrypted before being sent to back-end services like EC2 or containers. This allows organizations to enforce secure communication at the edge while maintaining flexibility in internal architectures. For hybrid environments, VPN connections are critical. With AWS site-to-site VPN, traffic between on-premises networks and AWS is encrypted using IPsec. This ensures that data traveling over the public internet between your data center and AWS remains private and secure. In practice, encryption in transit is often enabled by default, but customers are still responsible for choosing HTTPS instead of HTTP. Enforcing TLS policies. Configuring certificates correctly. Ensuring internal service-to-service communication is protected when required. For the exam, remember this key idea. Encryption in transit protects data while it moves, typically using TLS, certificates, and encrypted network connections. When you combine encryption at rest with encryption in transit, you get end-to-end protection for your data, both stored and in motion.
Alright, so at this point, go ahead and pause the video. Take a moment to read the question carefully and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer.
Now let's look at the next question and think it through together before revealing the answer. This question is asking about automatic encryption for objects uploaded to an Amazon S3 bucket, and it gives you a very specific requirement. The encryption must use AWS managed keys and it must happen automatically without relying on users to remember to do anything special. Here are a few clues to guide your thinking. Pay close attention to the phrase AWS managed keys. That immediately rules out options where the customer provides or manages the keys themselves. Notice the word automatically. This means the solution should work by default, even if someone uploads an object without specifying encryption settings. Ask yourself, which S3 feature enforces encryption at rest for every object placed in a bucket without requiring client-side changes? Also remember the difference between encryption at rest, how data is stored, and encryption in transit, how data moves over the network. Only one of those actually protects stored objects inside S3. Keep these clues in mind, eliminate the options that don't meet both conditions, and in the next slide, we'll reveal the correct answer and explain exactly why it's the right choice. The correct answer is enable S3 default encryption using SSE-S3. This is the correct choice because SSE-S3 uses AWS managed keys and, when configured as default bucket encryption, it automatically encrypts every object uploaded to the bucket, no matter how the upload is performed. Here's why the other options are not correct. Client-side encryption before uploading objects requires the customer to manage encryption themselves and is not automatic. ASSE. Customer-provided keys uses customer-managed keys, not AWS-managed keys. SSL/TLS protects data in transit, not data at rest inside the S3 bucket. So the key takeaway is, when you want automatic encryption at rest in S3 using AWS managed keys, the correct solution is S3 default encryption with SSE S3. This is a very common and important exam scenario. Before we wrap up this lesson, let me give you a clear big picture explanation of how AWS helps with governance and compliance, and then I'll ask you to pause the video to review the details on this slide. At a high level, AWS provides three groups of services that work together to keep your environment auditable, compliant, and well-governed. First, monitoring and auditing services help you understand what is happening in your AWS account. AWS CloudTrail gives you a complete history of API activity, who did what, when, and from where. This is the foundation for audits and security investigations. Amazon CloudWatch focuses on operational visibility. It collects metrics and logs so you can create alarms, dashboards, and detect unusual behavior. AWS Config continuously checks whether your resources comply with your rules and keeps a historical record of configuration changes, which is extremely valuable during audits. Next, compliance and reporting services help you prove compliance. AWS Audit Manager automates evidence collection for frameworks like PCI, DSS, and HIPAA, saving huge amounts of manual work. AWS Security Hub brings findings from multiple security services into one place, giving you a unified view of your security and compliance posture. AWS Artifact is where you download official AWS compliance reports, such as SOC, PCI, and ISO to use as evidence in your own audits. And a pool. Finally, governance automation and policy enforcement ensures rules are enforced before mistakes happen. AWS Organizations allows you to manage multiple accounts centrally and apply service control policies, which act as guardrails that prevent actions that violate governance or security requirements. Together, these services allow organizations to monitor continuously, audit confidently, enforce policies automatically, and scale governance without slowing down innovation. Now, I recommend that you pause the video for a moment and carefully read through the services listed on this slide. This is a very important summary, and many exam questions are built directly from these concepts.
Alright, so at this point, go ahead and pause the video. Take a moment to read the question carefully, and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer.
Now let's wrap up this lesson with a quick practice question. This question is testing whether you can recognize the AWS service that continuously tracks configuration changes and detects when resources drift from approved compliance rules. As you read the options, focus on configuration history, compliance evaluation, and ongoing monitoring of resource settings, not threat detection or API logging. Take a moment to think through it, and in the next slide, we'll reveal the correct answer and explain why. The correct answer is AWS Config. Why? AWS Config is specifically designed to continuously track configuration changes across AWS resources and evaluate them against compliance rules. It shows you what changed, when it changed, and whether a resource is compliant or non-compliant, which is exactly what the question is asking for. Why the others are incorrect. Amazon Guard Duty focuses on threat detection, not configuration compliance. AWS CloudTrail records API activity, but it does not evaluate compliance rules. AWS Shield Advanced protects against DDoS attacks, not configuration drift. So remember, configuration tracking plus compliance rules equals AWS Config.
Thank you for watching. See you in the next class.